In this part, we're going to further explore the complex numbers and kind of use what we learned so far and try the complex numbers on them. The first one is logarithmic. I wanted to find out the logarithm of a, okay? And before that, let me type a so we know that we're dealing with a complex number here. So if I say log of a and do the calculation, you see that the MATLAB has no problem to deal with that. And it's gonna be easy for MATLAB to calculate the results very fast. The other one is going to be exponential function of b. And let me type b here too. Exponential of b, so if I do that, you see that the MATLAB returns the value, and this value has a complex part and an imaginary part. You can do all sort of calculations here with complex number as well. So how about the sine of a? The same thing, and cosine of b, the same thing. So you see that you can do a lot of calculations when it's necessary, and so far what we learned, it just expands into many branches and you can try out what you learned in different occasions. Let me clear up the screen. Okay, one of the most important parts that we learned so far is the symbolic math. Okay, so the symbolic toolbox of the MATLAB is pretty powerful, and in this part I would like to show you how we can use that too. Let me type a and b here. We know these variables that we defined already, and I can find the angle of a, for instance, and the angle as we know is in radians. But if I type symbolic angle of a, and I literally put this function into a symbol function, and if I do that, the result is going to return like this. It's a very big numerator divided by a big denominator. The reason is MATLAB tried to return out the function into symbolic, so always keep in mind that passing symbolic function can return the values not in decimal but in symbolic, and here we were dealing with complex functions. And now what I'm gonna do is to repeat the same thing. So this was a, okay? Now let me define a as 3 plus 3i, okay? So it used to be -1, but now I try to change that deliberately to 3i, and I'm going to explain you why. So if I do that, now it is the new variable. Now if I say angle of a, it's going to return like that in radians. But if I do symbolic angle of a, now look what happens. You will notice that the result is no longer a giant fraction, but it is now in pi format. The reason being is that whenever I define my complex number so that the real part equals the imaginary part, then MATLAB can change that, can represent the result as a coefficient of pi. We can really use that. So whenever you have the same real parts and imaginary part, remember that by doing this, you can get the result. As you notice, the result for a with this real and imaginary part was exactly the same when it was a different number but value, because what matters is actually their division, which is going to be the same. Okay, so let me clear up the screen. Now I would like to repeat the same stuff for the functions that we learned, like the apps. Okay, so I do have a here, and I do have the absolute value of a, and now if I say symbolic value of apps of a, and yeah, I typed a b. Okay, so the symbolic is going to return it like that. Pretty ends, it's going to return it like this if you prefer that. My point is that you can do all of the calculations, all of the functions that I explained before in this part, and pass it to a symbolic toolbox as well to see what would be the result. And I just wanted to ask you to repeat the functions and the stuff that we're writing here on your own too, because that's the way that you learn MATLAB. It's going to be useless if you just watch these videos and not doing some practice or exploring things out of the scope of these videos, yeah, that would be great. And you will learn much faster.